Okay guys, this is the second video on the homework assignment. We're going to finish it up here. On the first video I jumped around on different questions and we're going to go back and finish this. So if we take a look at number 2, it says x minus y equals negative 4. And if we look for x minus y equals negative 4, you'll see it's right here, x minus y equals negative 4. So they're talking about this blue line. What else? And the other one is y equals x plus 4. So we're talking about the blue line, and we're also talking about y equals x plus 4. If you look for the equations, y equals x plus 4, it's this one right here, which means it's the same exact line, okay? The equations look different. X minus y equals negative 4, and y equals x plus 4. In other words, if I were to take this x and subtract it over here to this side, and then multiply everything by negative 1, it would be that same exact equation. I might as well demonstrate that for you. Check this out. So there's my original equation, x minus y equals negative 4. If I subtract x and subtract x, I will have negative y equals negative x minus 4. Again, you can't combine these, so you just rewrite it, this term first, negative x, and then minus 4 over here. So the only other step I need to do is to get rid of the negative sign in front of the y by multiplying everything by negative 1. But the bottom line is just going to change all the signs. Y equals positive x plus 4. So there's my new equation. And as you could see, that y equals positive x plus 4 is up here, the same thing, y equals positive x plus 4. So I've proven to you, I've shown you, demonstrated that this equation is the same as that one, which means it's the same exact line. So if you're trying to find the point that's in common, and it's one line that's the same exact line as the other line, it has an infinite amount of points in common. So if we go back over here for number 2, we say that the answer to number 2 is infinitely many solutions. Wait a minute, that's not right. They're not asking us to solve it. If they were asking us to solve it, then this would be the answer, that there's many answers, an infinite amount of answers. But they're not asking us to solve it. They're asking us to classify it, to determine whether it's consistent or inconsistent, whether it's consistent dependent or consistent independent. So obviously, when we think about this, let's scratch that out. It's not infinitely many solutions. But this line, it is consistent dependent. So this system is a consistent dependent system. So they're not asking us to solve. So once again, they're not asking us to solve. They are asking us to decide if it's consistent or inconsistent, and also dependent or independent. This is consistent dependent. Once again, from the word wall, we see that consistent systems have answers or just one answer, an infinite amount of answers or just one answer. If it is just one answer, that's what we call a consistent independent. Independent means one. If it has the same line, which is an infinite amount of answers, that would be consistent dependent. Again, independent, one answer; dependent, infinite amount of answers, infinitely many solutions. If they're parallel, they're inconsistent, they never cross, they never have an answer. You'll never be able to find an answer. Let's move on. Number 4, I spent way too much time on number 2, I'm sorry. If we take a look, let's look for y equals 2x minus 3 over here. Y equals 2x minus 3, which is right here, y equals 2x minus 3. They're talking about this line right here. I might as well color it red so we could see it better. There it is. And let's look at the other equation they're looking for. They're looking for 2x minus 2y equals 2. Where's 2x minus 2y equals 2? It's right here. 2x minus 2y equals 2. It's this blue line. So if we're looking at the red line and the blue line and call it a system, we know that this red line represents all the solutions of the red one. The blue line represents all the solutions of the other equation. So where's that one single common point that they share? The answer that works for both equations inside this system, it's right here. And that point of intersection is from the origin 1, 2 on the x, 1 on the y, 2, 1. So the answer is x equals 2, y equals 1. But then again, wow, I almost forgot. Once again, they're not asking for the answer. They're just asking for the classification. So this is called a consistent independent system. And of course, if you get confused with this, just look at the wall in our classroom and you will see that if they do cross, and they cross at one point only, it's a consistent independent system. Let's jump to the next question. Number 7. So the top equation, let's get it ready to graph. I'm going to use red ink. I'm going to subtract 3x. So my new slope-intercept form equation is y equals negative 3x minus 3. And you could clearly see that your m value is negative 3 over 1 and your b value is negative 3. It's really easy to graph because it crosses at negative 3. Start with your b value, crosses your y-axis at negative 3. And then from that point, you're going to go down 3 over 1. So from this point, you're going to go down 1, 2, 3 over 1. You're going to have a dot off the graph. But that's okay. Let's just put it down here off the graph. What I'm going to do, because if I draw my line here, it's not long enough. So I'm going to use the same pattern of down 3 over 1, but I'm going to go backwards. Over 1, up 3. Over 1, up 1, 2, 3. And I'm going to continue over 1, up 1, 2, 3. So let me draw my dots there. And now I have my red line going through those dots. Put arrows on it because it continues forever. Now let's do the bottom equation in blue. You want to get y by itself again, so let's subtract 3x. 3x, take away 3x is nothing, right? What you do to one side, you do to the other side. Let's rewrite it over here. Y equals negative 3x plus 3. Now right here, right off the bat, I don't even have to finish graphing this. I mean, I'm going to because they're asking us to, but I already know that these lines are parallel, which means that there is no solution. So my answer is no solution. How do I know that they're parallel? Because they have the same slope. You see there's a slope right here of negative 3. There's a slope up here of negative 3. They're the same slope. They're parallel. Let me draw it anyway. So this one crosses at positive 3. 1, 2, 3 right here. And then from that point, I go down 3 over 1. Down 3 over 1, and down 3 over 1 off the graph. As you can see, the red line and the blue line are parallel. They're never going to cross. So the whole purpose of graphing the equations of a system is to see where they intersect, because that is the x and y value that they share. That would be the answer to the system. So if they never cross, there is no solution. Okay, no solution. That's your answer. Now, if they asked us to classify it, it would be inconsistent, but they're not asking us to classify. Let's move on to the next one, number 10. Actually, number 8. Number 8, the top one's ready to graph. And of course, I want to graph it in red. I've been using that pattern. The top equation, I go in red. So the top one crosses at positive 2. The b value is positive 2. And the slope is the fraction in front of the x, which in this case is 1 over 1. So you go up 1 over 1. And when I say over 1, it's always to the right. So up 1 to the right 1. Up 1 to the right 1. And you could use that pattern backwards. So you go down 1 to the left, down 1 to the left 1, down 1 to the left 1, and so on to make the line as long as you want. There's my line. Let's go for the other one. The other one's not ready to graph yet. Let's get the y by itself so it could look like y equals mx plus b. So I subtract x, I'm going to have negative y equals negative x minus 2. Once again, right here the x is canceled, or they end up being 0. And then over here, the negative 2 and the negative x, you can't do it, so you rewrite it and you put your x first, so it's negative x, and then the minus 2 over here. I have negative y left on the left side of the equal sign. Negative y equals. Now all I need to do is multiply everything by negative 1, which is going to change all the signs. So my final equation in blue will be positive y equals positive x plus 2. Now, if once again, I could stop right here. I already know the answer. There is not one single point of intersection, but it's actually the same exact equation, right? If I look at this top equation, y equals x plus 2, and then I look at this bottom equation, y equals x plus 2, it's the same exact line. If I were to graph it, it would be the same exact line. So these lines land perfectly on top of each other. If I were to classify it, it would be consistent dependent, but they're not asking us to classify. They're asking us for the answer, which is the point in common. But as you can see, there's an infinite amount of points in common because it's the same line. So how many answers are there? There's an infinite amount of answers. So what is our answer? we say infinitely many solutions. Let's go to the next one. I'm going to speed it up a bit because we're running out of time. The top equation, I'm going to go with red. I'm going to get y by itself. I subtract x. I subtract x. I'm going to rewrite it. I'll have a 3y equals the negative x minus 3. Final step is to divide by 3. Divide by 3. Now remember, there's an invisible 1 in front of the x, and also divide by 3. So my final slope-intercept form equation for the top equation that I'm writing in red is y equals negative 1/3 x minus 1. So that one crosses at negative 1, and from that point I'm going to go down 1 over 3. Why down 1 over 3? Because I'm looking at my slope. So I'm going to go down 1 over 3, and I get that point right there. And I could go down 1 over 3, I'll be off the graph. And I could go backwards, over 3 up 1, so over 3 up 1 would get me right here, and so forth. Over 3 up 1 would get me off the graph. So I'm going to draw my line right through it, through those points. I'm going to put some arrows on it pointing to the ones that are off the graph. And then I want to go for my bottom equation in blue. Again, subtract x, subtract x. You're going to rewrite it. It'll be negative 3y equals negative x minus 3. Final step will be to divide everything by negative 3. So if I divide by negative 3, divide by negative 3, remember there's an invisible 1 in front of the x. Divide by negative 3. I will have my new final equation in slope-intercept form, y equals positive 1 over 3x plus 1. Why is it positive? Because a negative divided by a negative is positive. And the 1 divided by 3 you can't do, so you leave it 1 over 3. And over here, negative 3 divided by negative 3, that's really plus 1. So that one truly does cross the y-axis at positive 1. From that point, I go up 1 over 3. Sorry about all the interruptions. Anyway, so I could continue with the pattern of rise 1, run 3, rise 1, run 3. I'll be off the graph. So let's go backwards. Over 3, down 1, over 3, down 1, over 3, down 1. We'll get to that same exact point. And remember, we're looking for that point in common. So if I draw this blue line, put some arrows on it, what's the point that they share? This point right here. And what is that coordinate? From the origin, it's negative 1, 2, 3, comma 0, because you don't go up or down. It's right there. That location is negative 3, comma 0. So my answer is negative 3, comma 0. The only other thing to do, if you have time and you want to, which you should, is to plug in your x value of negative 3 and your y value of 0 into the original system. Plug in 0 or negative 3 right here and 0 right there. 3 times 0 is 0. Negative 3 plus 0 is negative 3, and you see that it really does equal negative 3. So what you've done right there is you've checked the top equation. And then you go back to the bottom equation and plug in a negative 3 for x right there and a 0 right there, and it will be negative 3 equals negative 3, because negative 3 times 0 cancels out. So negative 3 equals negative 3. So you've double checked it, right? And now you're absolutely positive that this is your correct answer. Number 10, the top one. Let's get y by itself by adding x. That'll make it disappear. Add x over here. Let's rewrite it. My new equation is y equals x minus 1. The bottom one, let's subtract x. Subtract x. The x's are gone. Let's rewrite it. We're going to have y equals negative x plus 3. So the top equation in red, it crosses at negative 1, the y-axis that is. From that point, you rise 1, run 1, because there is no number in front of x. So you automatically assume it's, or you know it's a 1. There's an invisible 1 right there. So it's 1 over 1 as a fraction. So you go up 1 over 1, up 1 over 1, and there's your line. Okay, now you might have to extend it further, which I'll do if I need to. And the blue one, it crosses at negative, or at positive 3. And then from that point, I'm going to go down 1 over 1, down 1 over 1. So I draw that line right there, and I see that they do cross, they do meet right here at that point. You could extend it if you want. You could extend this one. But they do cross at this location. And what is that location? From the origin, it's 1, 2 on the x. So as a coordinate, my x value is 2. And my y value, again, 1, 2 on the x, and my y value is 1 because it went up 1. So my y value is 1. And there's my answer, 2, 1. So the answer is 2, 1. Jumping to number 11, the final question to complete this entire homework assignment. Again, top equation, I'm going in red. I need to get y by itself, so I subtract x. Take away x is 0. Take away x over here. So let me rewrite it. It's going to be negative y equals negative x plus 3. And I need to change the minus sign in front of y. So I'm going to have to change all the signs by multiplying everything by negative 1. So my final equation is positive y equals positive x minus 3. Let's graph that red equation. It crosses at negative 3 down here. From that point, again, think about the slope in front of it. There's really a 1 over 1 in front of the x. So if you go up 1 over 1, up 1 over 1, up 1 over 1, there's your line going right through those dots. Put some arrows on it. Let's go for the bottom equation in blue. Let's subtract x. Subtract x. I'm going to have a negative 2y equals negative x plus 3. Then I'm going to divide by negative 2, divide by negative 2, divide by negative 2. Let me rewrite my equation. This cancels out, so I'll have y equals, once again, a negative divided by a negative is a positive. And also remember that there's an invisible 1 in front of x. So what that means is that I have a positive 1/2 in front of the x. And then the final, the b value on the blue equation is 3 divided by negative 2. That's really going to be a negative 1.5. What's half of $3? $1.50. And it is negative. So this one does cross at negative 1.5. So let's go to the negative 1 on the y. Negative 1.5. Negative 1.5 would be right here. Negative 1.5 on the y-axis in the negative direction. So let's put that dot right there, halfway, negative 1.5. Now from that point, I need to go my slope up 1 over 2. So from this halfway point, I want to go up 1 to this halfway point and over 1, 2. I want to put a dot right there. So there it is. And from that point, again, I'm going to go up 1. But remember, you're at the halfway point. So you go up 1 to the next halfway point. That's 1 unit. And then you go over 2 again, and you put a dot right there. So let's put the dot right there. Let's draw our line. It's kind of ugly. Now, as you could see, it looks like the point of intersection is right here at the location 1, 2, 3, 0. So 3, 0 is the location 3, 0. Now, if you're kind of weirded out by that, the answer being 3, 0, let's test the values. So let's go to the original one. The first, and I'm talking about the original system. The top equation is x minus y equals 3. If I plug in a 3 for x minus 0 for y, does it equal 3? And you'll see that yes, it does. If you go to the bottom equation on the original system, it says x minus 2y equals 3. And if you were to take the x3, plug it in right there, the x being 3, you're going to have 3 minus y, actually minus 2y, which is minus 2 times 0, and it should equal 3 also. And you will see that it really does, because 2 times 0 is nothing, and 3 does equal 3. So you've double checked it. You're absolutely positive that this is the correct answer. So it looks like we've done every single question, on this homework assignment. That's with both videos, the first video and the second video. Make sure you know this stuff. This will be on the next quiz. It will be on the next test. Good luck.